Welcome to Spring LIB.
In this problem, we are practicing our differentiation skills, specifically with using inverse trigonometric functions. And also, this is a great example of a very informal proof, and this is a great precursor to future math classes that you might take. We are given the function y equals x times the inverse sine of x plus the square root of 1 minus x squared. So we have to differentiate this to prove that we get the inverse sine of x. We're told that's what we have to wind up with. So y prime, our derivative, would be equal to the derivative with respect to x of x sine inverse x plus the derivative of the square root of 1 minus x squared. So how am I going to do this? Well, this first term looks like a product, so we're going to use the product rule. And the second term, we're going to use chain rule. So when we apply those rules, we'll get that y prime equals the inverse sine of x times 1 plus x times 1 over the square root of 1 minus x squared plus 1 over 2 times the square root of 1 minus x squared times negative 2x. So hopefully that made sense how we went from product rule to chain rule to get this derivative here. And then we can simplify it. We can get y prime equals the inverse sine of x plus x over the square root of 1 minus x squared minus x over the square root of 1 minus x squared. Well, these two terms are the exact same with opposite signs, so they can cancel. So we're going to get that y prime equals the inverse sine of x, just as we were supposed to. The problem tells us that that's what we have to find. So I hope that this problem helped you understand a little bit more about differentiation, how we can choose the rules to differentiate, and then I hope that this helped you understand a little bit more about an informal proof, or maybe what to do when a problem tells you to prove something.